Technical Society, Sri M.S. Jain Memorial Biennial Prize for the Best Paper on Innovation in Piling and Other Foundation Construction Techniques for years 2009 and 2010 for research paper titled Ultimate Pull-Out Capacity of Granular Pile Anchors in Homogeneous Ground, published in Indian Geotechnical Journal and International Association of Lowland Technology. Awarded Best Papers for Elastoplastic Analysis for Displacement of Granular Pile Anchors in Non-Homogeneous Ground for research paper presented at ISLT 2008 and published the same in Lowland Technology International Journal. May I now invite and request Dr. Bundy to make the presentation.
Good evening to everybody, and thanks to the host for the warm introduction. Thank you, sir. Thank you. And it's a tough times during the COVIDs that we have to do it remotely, and I don't have a privilege to meet you all in person. But certainly look forward for meeting you all in person in the coming times. So I'll just share my presentation and quickly So can I start? Is my voice audible to everybody?
Yes.
Okay. Thank you. Today's topic is on the ground engineering or the ground improvement by deep soil mixing techniques and the jet grouting techniques. One of this, the deep soil mixing technique is a very, very innovative technique and technology which is used for improving the soils, wherein it bypasses or it is more efficient and effective when considered in terms of the traditional techniques. So moving forward, we just like to understand, or we will be discussing about what exactly is deep soil mixing, what is its construction methodology, and what are the different kinds of equipment that are needed for installing a deep soil mixing columns. Then what is the materials that are required for installing the columns, and after that we will be discussing at the quality control measures. How do we ensure that the columns which are installed are able to take the design load, or able to match the design requirements what we have been working on. This is in general, like I just wanted to brief you, tell you we will be discussing the equipments and methodology, the construction material, and the quality control checks. So when we talk about deep soil mixing, it is nothing but like we are mixing the in situ soil with external material like cement grout, a mixture of cement, bentonite, and plasticizers, so that like what we are doing is we are trying to increase the bearing capacity or modify its shear strength parameters, so that like the soft soils can able to take the loads as per the design requirements. And added, this is a very, very innovative technique because it uses the in situ soil. So there is no problem of disposing the soil like what we do in the pile foundations, and bring in external material what we have to do in like stone columns, wherein we have to bring the stone from far off places, and we have many hindrances or approvals at current environmental issues. So the main advantages are like we are using the natural soil and limiting the waste. So it is more or less a sustainable solution, and we are optimizing the resources and the movement of equipments and movement of trucks and other things to dispose of the muck or bring in the material is more or less optimized. And this technique is completely vibration free, and it can go up to a depth of 20-22 meters without causing any sort of vibrations. And moreover, it is not disturbing the nature or the soil structure wherein we are doing this particular DSM columns. and we are able to achieve a predefined geometry how we wanted to install. So looking at it, what is the basic component of this particular system is the mixing tool and nozzle which through which the grout is being ejected or where it is being pumped into the soil and it is being mixed with the help of a series of blades and paddles into the in situ soil. So what happens is like we have a guiding system at the top which helps to ensure that the verticality of the drill strings are properly maintained, and we have a rotary dive which ensures that the torque, the defined torque is also maintained, because this has an advantage of what do you call as like increasing the speed, or we can do it at a controlled RPM so that the blending or mixing of the soil is happening properly. So the DSM installation process, there is basically two steps. One is that we are preparing the working platform, then we are mixing, then using the mixing tool, we are penetrating into the deep ground, mixing the in situ soil, and we are coming out. So this is called as downstroke when we are going down, and when we are coming up, it is called as an upstroke. So this is a generalized picture how we have to set up a site. Like we will have the complete quality control lab has to be there, a workshop, the cement silo should be there, and the mixing plants in order to supply the cement slurry, which needs to be pumped into the soil for blending the soil with the augers, and the hydraulic piling rigs in order to like take the desired auger to the depths of the installation. So when we look at in detail the equipments, we have the cement silos, then we bring in the amount of cement that is required per cubic meter of soil. For this, we will have to initially do a trial columns and establish what is the amount of cement that has to be blended into the soil so that we are able to achieve the desired strength. Then from the mixing plant, it goes into the agitation tank. The cement is continuously being mixed so that like there is no formation of clogging of a cement balls. And with the help of a monopump, here we have to very clearly understand that like there are two types of pumps. One is a centrifugal pump and other one is a monopump or a screw type pumps. Wherein if we use a centrifugal kind of a pump, what happens is like it distorts the complete soil structure or the grout mix design, so that it is always advised to use a monopump or a monopumps. Along with the help of a compressor, we are able to reach up to the desired location. So this whole setup is installed at one particular location, and using that, like we were able to move our piling rigs so that we can install the DSM columns. So from the compressor, it has been pumped into the augers, and the auger, the cement slurry is passing through the tube, and through the auger, it is going to the bottom of the auger and it is mixing the soil. So as I was mentioning, like there is a two process, like we always have a question like how we ensure that like the amount of soil and the cement blending is properly happening. So for that reason, we will have to do multiple trials on the site to establish what is the amount of cement that needs to be blended during we are advancing into the ground, and how much will be like the balance, or we'll have to monitor all these parameters, like it is called as a downstroke and upstroke. Almost all 70% of the cement slurry is mixed during the downstroke, because almost all we are mixing the soil, the virgin soil, we are mixing with the auger. And during the upstroke, we are almost of the balance, 30% of the mixed slurry or the volume is mixed, and almost all it is more or less we are able to create an homogeneous column in the ground. So looking at the DSM execution sequence, like if you want to do it as a single columns, I'll just show you different case studies or execution what we have been doing in India and Bangladesh. So first we'll have to install the first row, and in the first row also we will do the primary number of primary columns. That is like we will be doing the primary columns. Then when we do the primary columns completely, like almost all the 20 numbers or 25 numbers of primary columns, Then we come back again and start mixing the secondary columns or the intermittent left out columns so that it forms a continuous row of columns and which is almost all impervious or watertight. Then after executing this particular row, we will have to move into the third row. Sorry, I'm but row one and row three. So we move into the third row. We follow the same process. We do the first ones completely like a number of 20, 25 columns, then come back and do the secondary columns. This process can be like, if this we are following an overlapping DSM columns, we can adopt an overlapping. If we don't require an overlapping and if it has to stand like an individual column also, it can be installed like an individual member. Now, after installation of the first and the third row, then the second row is been installed so that it completely forms an homogeneous soil in the ground. So the main equipments, we will then quickly run through the equipments. Now we have looked into the methodology. We will now also look in detail. The main equipments is like the key component is the cement silos, wherein cement is being used, and other silos we have to also stock the bentonite and if required uh, additional amount of cement so that like we don't run out of the inventory at the site. Then the mixing plant should be there so that it is able to match our requirements. Like either we are able to pump 40 cubic meters per hour or 30 cubic meters of slurry we are pumping. So all these parameters needs to be established before start of the works so that like when we are starting the production, so we don't have any sort of hindrances. So like this was a batching plant, like wherein the cement and bentonite and plasticizer are mixed in and it has been continuously agitated or mixed in. Then this is another kind of a make like manufactured by Techniwell. Then we have vegetation tanks. When the amount of cement, bentonite and plasticizer are mixed, the mixed slurry or the grout slurry has to be continuously kept in agitation so that it doesn't settle down and create an non-uniform slurry when during the pumping. So that is next is the screw pumps or the mono pumps what we have to use to ensure like it reaches up to your the drilling rig for installing the DSM columns. And other one is the air compressor to facilitate movement or avoid clogging of the cement slurry in the distribution pipes and the drilling rig for installing the DSM columns. So this you can see here like we are continuously been installing the DSM columns and the top additional muck which is just coming out has been disposed of and the ground is made leveled. So we also have to ensure that the quality of the material that is being used for the DSM columns are matching the specifications. Like we have to have a completely clean and uncontaminated groundwater so that like the cement slurry is able to achieve the desired strengths and the cement matching the specifications to achieve the desired compressive strengths. So when we move into the quality control, like we are discussing about the DSM columns being installed, but how do we ensure that like the columns which are installed are able to give us the desired strengths? So first thing is like we'll have to ensure the composition quality and the solidity of the stabilized soil needs to be checked, for which we will have to take samples at a different interval or a different depths so that like we are able to ensure that the quality of the DSM columns is properly done. So like usually like we are able to achieve compressive strengths up to 2 MPa to almost all 4 MPa and modulus of round about 100 MPa to 200 to 300 MPa also. And we are also able to increase the shearing resistance, angle of shearing resistance up to 35 degrees, like which is very significantly very high value when we are trying to improve the soft soils. Apart to that, like the cement slurry has to be continuously tested for the density, sedimentation, and the bentonite has to be tested for its marsh cone values. and its viscosity and density also. So sampling, we have different techniques, like this is called as a wet grab sampler, wherein the DSM column once installed, we can able to collect the soil sample from a different depth and cast an mold of a vacuum sampler of 100 dia and 200 That is like we will be doing a compressive strength test to ensure that the strength parameters are achieved. Then we have to also ensure the water matches the specification, the cement supplied by the suppliers, and the slurry and the stabilized soil and the hardened soil. So when we look at the frequency of the test or quality control checks that needs to be done on the cement, we have to check on the fresh cement, what is the mineralogy that has been used of the cement that has been used for the production of the DSM columns. Then the compressive strength of the DSM columns for every 7 days and 28 days. There is a frequency that has been defined by the international codal provisions, and the fineness of the grinding, setting time, and uniformity of the volume change. So all these things we need to ensure as per the frequency that are mentioned as per the codal provisions. And also mixing water, we have to check for the chemical analysis and express analysis. Then the cement slurry, we have to ensure the slurry is having the proper density, mass viscosity, and the right temperatures so that like the composition of the mixed slurry is not distorted. We need to have a complete setup of the laboratory at the site to ensure that we are able to check the soil samples collected from the wet sampling and carry out a uniaxial or a triaxial compression testing on the samples so that like we can able to establish the parameters of the soil, the modulus and the compressive strengths. And they have to be like, we can also check for the permeability of the samples and the curing. So for all this, we have to ensure that the soil samples, because we are using a cement, we'll have to ensure that all these samples are cured for 7 days, 14 days, and 28 days categorically. Then the question comes, how do you ensure that like the columns that are installed on the site are also having the verticality, or is there any deviation? Are we are able to inject the right amount of the volume of the slurry into the ground? Are we are able to reach up to the depth of the soil? And what is the pressure? Because we have to ensure that the supply of the slurry has to reach continuously in the desired quality and the desired quantity, so that like, is it reaching the auger in time and we are able to pump in and pump out, like pump out the volume as at the given time at the given depths, so that like the nozzles doesn't get clogged, because we are using a cement slurry. That the chances of the settling of the cement all along this tiny pipes or the minute opening can sometimes hinder the quality control of the DSM columns being installed. So Bauer has a unique system that is called as a Beatronics in every equipment, wherein we are able to monitor what is the depth, what is the RPM of the equipment or the auger that has been installed, and what is the rate of pumping at what depths, what is the discharge capacity that is of the slurry that has been pumped into the ground, and the volume of the slurry that is been pumped out. All these things are monitored by the operator sitting in the cabin of the drilling equipment. So another important feature what even Bauer has is that like we have an in-house software called as a B project, wherein the projects can be completely monitored globally, and we can able to see that like what is the completion ratio, what is the time taken for the each DSM column to be installed, and what is the utilization of the equipment that is being working on the site. Are there any breakdowns? Is the discharge capacity being able to pump, or we are able to install the desired number of columns in a day or not? So everything can be monitored on a day-to-day basis, and even check the consumptions and the efficiency of the equipment, so that like we can able to speed up the production and ensure that like we're able to match the construction timelines. So this is a log which is generated in the B project, like wherein which is come from the Beatronics installed on the drilling equipment that gives the complete details like what is the penetration rate, what is the RPM that is we are installing, and what is the volume of injection, the grout being injected when it is going downstroke and it is being withdrawn or upstroke. So this helps us to have a complete quality control of the DSM columns that is been installed so that like we are able to achieve the desired efficiency on the ground. This is a quick video of overlapping of the DSM columns. So just a overview, like how does the site look like? You can see like when continuously we are working, it is bound to happen. We'll have a slurry, but more or less since the mug disposed or the mug generated from the DSM columns is substantially very low when compared to other techniques. So more or less the site looks this way like. So coming to another Indian project, and I wish to like make a statement here that like Bauer is the first company in India to introduce the DSM columns, and we are doing it at the Polar Mitigation project to strengthen the diaphragm wall, which was also installed by Bauer in 2018. So if we look at it, this is a gap one and this is a gap two, wherein we are trying to strengthen the blue line. What you see is the DSM, sorry, is a concrete, plastic concrete cutoff wall, and it also has a limited strength. But the river is on the downstream side or on the basin of the river Ganga, sorry, Godavari. The scouring depths are very high, and the chances of damage to the plastic concrete cutoff wall are significantly very high. So in order to ensure that like this particular cutoff wall, plastic concrete cutoff wall is properly protected so that like the impact of the scouring or the flood underwater current of the river is minimized by installing the DSM columns and also parallelly doing stone columns all along the width of the dam. So almost all this is 1.4 kilometer long main dam, and this is the side one, which is around about like 350 meters. So to have an overview, like how does it is been installed, like across the width of the dam, we are able to do or we are doing DSM columns to a depth of like 15 to 22 meters in gap 1 and gap 2. Apart of that, like when the stone column has been installed here, there is a probability that this change in the strength of the soils is so sudden that like the DSM, the cutoff wall has a high strength, then the DSM has a slightly reduced strength, and stone columns have further slightly reduced strength. But the transition has to be so smooth so that like in order to ensure that the strength dispersion along the width of the dam is properly done, we have designed a transition zone of around about another 10 meters to ensure that the soil parameters are more or less decreasing towards the width of the dam, because here the height of the dam is also quite high and the stresses are also quite high. So to make it more clear, we have almost all a quantity of 2,06,000, but it has significantly gone up, and we are now are doing close to 250,000 or 2.5 lakh running meters of DSM columns. And we have almost all completed installation of around about 60 to 70,000 running meters on the DSM columns. So that too, we have done it in the construction schedule or the schedule proposed by the client. So we took the responsibility because we also have an in-house design team wherein we do the mix design and we do the DSM columns. So you can see here the installation process. Like here, almost all we can see here the DSM quantity has gone up. Like now again, it is still expected to go up. Looking at the efficiency of the system that has been installed, the client is very happy with us, and we have achieved 2 lakh man hours on this particular job site without even a single incident or near miss incident. So that is also one of the key factors of the company. So you can see here, this is the plastic concrete cutoff wall, and we are installing the DSM columns on either side of the DSM columns as I've presented. So this gives you an overview, like from the top, like how it's been set up. Like this is a plastic concrete cutoff wall where we are installing the columns, and the batching plant, which is catering to the requirements of the cement slurry, which is required for the injection. And we are here roundabout pumping close to 330 kg of cement per cubic meter of soil that has been improvised. So I'll just quickly show you the video of this particular site also. Hope the video was very clear when we discussed about what are the different equipments, what are the different kinds of stages of the mix design or the some pumping of the cement slurry and installation of the DSM columns, that too downstroke and upstroke. So that I think this video would have clearly established an overall construction process of the DSM columns. Next, moving on to the grouting techniques, there are different kinds of the grouting techniques available for improving the soil under different applications. But we look at like we have permeation grouting, soil fracturing, compensation grouting, compaction grouting, and jet grouting. Depending on the soil requirements and the improvement of the soil that needs to be done, the appropriate technique needs to be established and it has to be executed at the site. Before I talk more on jet grouting, I just wanted to have that like all of us should have a feeling of like the other techniques. So I have included few slides on the top 4 technologies also. Basically, the grouting techniques is all dependent on two types, like or they're classified into two techniques. Like one is without soil displacement, other one is with the soil displacement. In the without soil displacement technique, we are trying to fill in the cavities because more or less when we are working on a lateritic kind of a soils or muram kind of a soils wherein we have or calcareous kind of a materialistic soils, the probability and chances of formation of cavities are quite high, which is predominantly visible in Kerala, Dakshin Kannada and Karnataka region of the Western India. So we are not even displacing a bit of a soil from the ground, but we're able to fill the pockets and we are able to ensure that the soil integrity has been maintained. Then the next one is the permeation grouting. In the permeation grouting, we are trying to inject the grout in between the voids of the soil so that like the soil structure has been densified and the soil strength is overall soil strength or the modulus of the soil has been improved. Next, with the soil displacement, like we have compensation of the soil fracturing. Here again, we are trying to inject the grout at multi stages and we are trying to crack or fracture the soil so that it forms more or less like a column and the strength of the soil has been increased. Last one is the compaction grouting. This is basically used for granular soils or a sandy kind of a soils, wherein we are introducing a very low viscous cement grout so that like bulbs are constructed in a certain heights and then it forms a column kind of a thing. So permeation grouting is basically like for high permeability soils like gravel and sandy type of a soil. We are trying to inject a TAM pipe and we are trying to fill in or we are trying to inject the grout into the soil so that the existing soil has been improvised. Then is soils having very low permeability, that is soil fracturing. We are trying to like crack the soil or introduce the grout and wherever there are fissures, cracks, or like there are like the soil strengths are weak, we are trying to induce it so that like the overall strength of the soil is again improvised. So compensation grouting is basically is done like when we have to ensure that the existing structures close to any of this underground activities like tunnels, shafts, or any other activity, piling activities are being carried out close to the existing buildings or structures. So we are doing an horizontal grouting so that like the foundation soils of this particular buildings or the structures are not disturbed and we can able to continue with our infrastructure projects. This is just to mention like how exactly a TAM pipe looks like. It has fissures at a different levels and through which the grout is being injected uh, at different pressures and different levels. Then we are looking at the compaction grouting. As I said, like the compaction grouting is basically a low viscous grout has been injected into the ground and thus it forms bulbs in certain heights, motor bulbs, and so that like we are more or less coming and creating a column here under the foundation, and we are improving the existing soil to match our foundation requirements. You can see here the grout. Now moving into the jet grouting basically is of 4 systems. Like one is when we are talking with high pressure injection of the grout, or we can also introduce compressed air with the support so that like the column is able to form or the injection or the blending of the grout is happening thoroughly into the soil. So that like you can notice here with only with a inject of high pressure grout, we are able to form a smaller diameter column. Whereas with the help of air, we are able to even create a bigger size columns in the ground. Next, coming to the two-phase system, wherein we can use ground, what you call as water and the ground, and it has been introduced at different levels so that like the blending or the mixing of the soil happens properly. And all these phases or the different techniques are dependent on the type of the soil what we are executing and what is our requirement and what is the end result that we are anticipating. So looking at the jetting system, basically we need water for the jetting when we are introducing the jet grout into a depth of into soils or modifying the strength of the soils which are less than 75 microns, because as per the Indian codal provisions, anything which is less than 75 micron is considered to be clay and silt or highly cohesive soil, and all the soils above 75 microns we treat them as non-cohesive soils, or non-cohesive soils are the sandy type of materials. So it is like we need to use water for jetting when we are working mostly in the clay and silty type of soils, and sands up to like only 2 microns or up to 1.75 microns. But with the only grout, because here the size of the pores are bigger and the percolation of the grout is happening very smoothly. So we can able to do even without the help of water. Just to show you like what is the effect of the air on the formation of the columns. When we are drilling without support of air, we are able to form 1.45 meters diameter column. Whereas when we are introducing with respect to air, we are able to almost install a columns of 2.2 meters. And we are maintaining the other parameters of installation. That is like the withdrawal rate we are maintaining at 6 minutes per meter, and pressure of 400 bar. And it also has an impact on the duration of the installation, because if we are maintaining a less duration, we are only able to form a 2.1 diameter column. If we are able to maintain for more time of 6 minutes, we are able to form a column of 2.5 meters. And we are still maintaining 9 minutes per meter, we are able to achieve 2.7 meters of column. So it all depends on the requirements, the type of the soil, the pressure, and the installation duration of the jet grouting. It also has an advantage, like we are able to construct the complete 360 degrees or a complete column, or we are able to also install sectoral angles like half columns, because when we restrict the movement of the nozzle only in 180 degrees. Uh, Trials are on for even installing 4-meter diameter columns, but it is still at a very initiative stage. So, but works are going on to ensure like we can able to install a bigger columns also. So this is a recently completed project in Tista, Sikkim, wherein we have done round about 4,600 square meters of jet grouting on the upstream side, Coffer Dam. The upstream side Coffer Dam, you can see here, this was the upstream side of the dam, and we had to install jet grouted surface so that like the percolation of the water doesn't happen and the safety of the dam has been maintained. So we have recently completed the installation of this whole jet grouting. And this is the drilling equipment, what I was mentioning. It has a drill string, and we were able to reach up to a depth of 39 to 42 meters in this particular project. So thank you. Thank you everyone for your valuable time. I hope I have ensured I am well within the time.
Yeah, thank you, sir, for your presentation. Now we have question and answer. If participant have any question, they can ask directly to the presenter.
Can I ask one question?
Yes, yes, please.
Okay, hello, Dr. Vidyaranya. I am Dr. Akanksha Tyagi. I am Assistant Professor at Civil Engineering Department, IIT Roorkee. And my research interest also include in situ ground improvement techniques like deep soil mixing and jet grouting. So I really liked your presentation, and because I didn't find any literature of deep soil mixing or jet grouting being done in India, so it was really informative. I would like to ask, like, how do you ensure the permeability at field, and also how do you test it at laboratory? Because we see lot of core testing data, UCS data, but I seldom see permeability data. So how do you ensure that?
Madam, like we have the water drop technique or the as per the codal provisions. It is the same like what we have in the triaxial testing equipment, but only the difference that is made is the size of the sample. In a triaxial sample, we have a 5 mm diameter, sorry, 5 centimeter diameter and a 10 centimeter diameter sample that we take from the undisturbed soil sample from the cores. Here, we are making a bigger sample because we wanted to have a check on the overall homogeneity of the soil, how the cement and the bentonite have blended with the soil. So here what we are doing is we are making a bigger column, a bigger sample of 10 centimeters and height of, because you are well aware that we always have to ensure L by D ratio greater than 2.
Hmm.
So when we create it, when we cast the sample and cure it for 7 days, 14 and 28 days, and in the triaxial setting equipment, like we can monitor like what is infiltration, what is percolation time duration for the water, uh, for, for traveling of the water from the top of the sample to the bottom. So that is how we can.
Okay. So basically, you measure permeability using triaxial cell.
It's basically, I'll tell you, madam, one other point. See, it all depends on your requirement. Either you're looking at the strength or either looking at the permeability. Because as I showed, that is the reason I show you the two techniques of the columns that have been installed. In one project, we were overlapping the columns, but in one project, we were installing independent columns. The second system was in follow-on project to act as a strength member, strength barrier or an impact, reduce the impact of the what you call as the pressure on the existing cutoff wall.
Hmm.
So, or we wanted to create a complete impervious layer, then this amount of cement has to be slightly higher, and we can create a barrier all along the boundary of the structure or the plan, so that like we don't get the water, and we can able to easily excavate by lowering the water table around this boundary of the plan.
So thank you.
We are working on a project at a very initial phase. There are soil mixing techniques. There are many technologies in place. Actually, my colleague uh, Peter, who has made a presentation at from 12 to 1,
Yes.
he's our global expert on all these mixing kinds of technologies. Like we have cutter in mixed place, we have auger in mixed place, continuous flight augers. There are different technologies how we can modify the strength of the soil. And all again bottles down to what is the requirement, what is the construction schedule, and what is the quality assurance requirements of the clients or the project.
So, can I have a request of your email ID to discuss any possibility of research collaborations? Some of my students, they want to work with the data, with
Definitely,
statistical.
definitely, madam.
Okay.
Mr. Sunil Sharma ji, who has been actually coordinating this particular lecture, has my contact details, my email IDs. So, or even I will definitely try to ensure they are passed on to you.
Okay. Thank you so much. Thank you.
Thank you, madam.
Thank you, sir.
Thank
Any
you.
more questions? If there are no questions, then in that case, let us have a huge round of applause to the speaker, Dr. Bandi, for making an excellent presentation, giving complete details about the soil compaction as well as the grouting techniques. If still some people have questions, they can send in by email to the organizer. We will get the answer from the speaker and revert back to you.
Okay, sir. Thank you.
At a later date also you can do this. So with this, I think we are thankful to the author, Dr. Bandi, and also to the participant for their patience hearing as well as interaction, and looking forward to the such interaction in future too also. So thank you very much, and we can close the session.
Thank you. Thank you all once again
Thank you.
for patiently listening to me.
Okay.
Thanks.